An airplane is traveling with an airspeed of 320 miles per hour and a heading of 62 degrees. A wind of 42 miles per hour is blowing at a heading of 125 degrees. Find the ground speed and the course of the airplane. So this really is, let's go ahead and draw a picture here. We'll use a vector to represent the plane flying at a heading of 62 degrees. So this right here, that's 62 degrees. Okay, and the speed of the airplane will be the magnitude of this, 320 miles per hour. But then there's also a vector that represents the wind. Okay, and we're actually just going to tack that on to the airplane vector. So we've got the 42 miles per hour blowing at a heading of 125 degrees. So that's going to be, well, 120 is right around there. So something like that. Okay, and so this angle here, that is 125 degrees, and the length of this vector is the 42. Okay, so as the airplane flies, the wind blows it a little bit off course. Okay, we're looking for what that airplane ends up doing, which is this resultant right here. So that's the sum of these two vectors, and that, in order to find that sum, we are going to need the components of these vectors. So we'll let the airplane components, we'll let that vector be A1, A2, A for airplane, and the wind, we'll let those components be W1 and W2. So using what we know about components of the vector and how they relate to the direction, the angle, and the magnitude, we can get each of these components. A1 is the magnitude of the airplane vector, which is 320, times the cosine of the angle, 62 degrees. A2 is the magnitude, 320, times the sine of the angle, 62 degrees, and then do the same thing for the wind. The horizontal component is the magnitude of the wind, which is 42, times the cosine of the direction angle, and the vertical component is the magnitude times the sine of that angle. So now we're looking for the sum of those, airplane plus wind. So that's going to be A1 plus W1, these two here. Go ahead and just write that, 320 cosine of 62 degrees plus 42 cosine of 125 degrees. And the vertical component is the A2 and W2. Go ahead and add those together, 320 sine of 62 degrees plus 42 sine of 125 degrees. And that is what then we want to compute. I'll go ahead and plug these into our calculator. So we have 320 cosine of 62 plus 42 cosine of 125. I'm in degree mode, so I'll go ahead and hit enter here, and that gives me that first component, about 126.14. Now for my second component, I have 320 sine of 62 degrees plus 42 sine of 125 degrees. And go ahead and hit enter, and we get 316.95. So that is the components of the vector that is the course of the airplane after taking into account that wind. The question is, find the ground speed and the course of the airplane. Well, we have these two components, but that's not really the ground speed or the heading. You could make an argument that it is the course, but let's go ahead and find the heading, the angle, as well. So we'll start with the drawing just a quick little picture, actually. So we've got this angle, or sorry, this new vector, and we are looking for the length of it, and then of course this angle here. As far as the magnitude of it, we have a formula for that. We know that the magnitude of this, I'm going to do this, we'll call this vector v. Okay, so the magnitude of v, of course, is the square root of the sum of these two components squared. And I'm going to make sure that when I'm actually computing this, I'm using the exact forms that I got in my calculator. So back to my calculator, those were my two numbers, and I'm going to use those full exact numbers. So I'm going to come up and highlight, hit enter. So I've got that number, I'm squaring it, and then plus, I've got the other number, that's this one there, and I'm squaring that. And I forgot to do my square root. It's okay. I'll go ahead and hit enter, and then we'll take the square root of that answer. Okay. So there is my magnitude of this vector. This is the ground speed of the airplane. So about 341.13 miles per hour. Now we're also looking for this angle here, and actually we can get that by going to this triangle. The angle, I should say the acute angle that the vector makes with the axis, the x-axis, I can think of as an inverse tangent, where I've got my vertical component here, my horizontal component. To get this angle theta, we're going to take the inverse tangent of the vertical component divided by the horizontal component, right? Opposite over adjacent. So that's going to be the 316.95 over the 126.14. Now this is, of course, just the acute angle that the vector makes with the x-axis. You do have to check the quadrant in order to actually find the heading of the vector, the actual angle. Let's go ahead and do this here. We've got the inverse tangent, so I'm going to go and do my trig and go down to my inverse tangent of a fraction, and that fraction is let's see if I can pop those numbers in. I had my 316 right there, and then divided by, unfortunately I didn't, I can't copy, it's not gonna, I don't think it's gonna quite work. I'm just gonna go ahead and copy it down. So 126.1406.898. .06898. All right, and then hit enter, and that gives us our acute angle. I'll round that to 68.3. So 68.3 degrees. Now, this is the acute angle that my vector makes with the x-axis. Because both my horizontal and vertical components of the vector are positive, I know that my vector is in the first quadrant, and so this is the correct angle. If the vector had been, say, in the second quadrant, like somewhere over here, I'd be looking for this full angle, but the inverse tangent would have given me this angle, and so I would have gotten my heading with doing 180 minus the angle that I got. So you just have to think through what the angle is that you actually are trying to find and what the inverse tangent actually gave you.